Welcome everyone. So in this lecture we're just going to look at the basic program that we discussed in the previous video lecture, and we're going to play around with the code and see what happens. As you can see, this is the code that you saw in the previous set of slides. It's just that it was on the slides there. Here I have put it inside the Visual C IDE. But other than that, it's just the same code. So you have the preprocessor directive with the hash include stdio.h. Then you have a comment, then you have int void main, and then you have the print statement, and then finally your main function basically ends here. And one of the things that people generally do or is advised is whenever your function ends, and we discussed this in the previous lecture, that your function basically should be included inside these curly braces. So wherever you put the curly braces to end your function, it generally is good practice to write a statement which tells you which function is ending over here. So here we've said that end function main. So what that means is that the main function ends over here. Now this may not seem very appealing right now, but let's just say if your function consists of hundreds or thousands of lines of code, then this comment will be very useful because it will tell you where exactly your function ends. Okay, so without any further waiting, let's just quickly run our program and see if it runs error-free. So let's go ahead and click on this green button here, which will first compile and then run the project. And you can actually see that in the command window right on top, you get the message welcome to C. And then you get one line, and then on top of that there's some additional information which you did not really ask the computer to print, and this is not being printed by your program. This is some extra information which is added by the Visual Studio environment, but your program basically what it's doing is just printing the welcome to C. Okay, and now this program basically ran error free. So if you look at the error window here at the bottom, you'll actually see that you get 0 errors and 0 warnings. So your program basically has run. Okay, now what I want to do is maybe introduce some errors into this program and then see what happens. So the first thing that I'm going to do is I'm going to remove this semicolon here and then see what happens. And you can actually see straight away that this red kind of light turned on immediately, and it kind of tells you there right now that that the Visual C already knows that there is an error. It is telling you that it expected a semicolon and it hasn't found one, so it's giving you a bit of a hint on how to find it before running. But let's just say you removed it and then you run, you want to say, alright, let me see what happens. So let's just go and see what it does. It says there were build errors, would you like to continue and run the last successful build? And so I don't want to run the last successful build, I'll just stick with this one, and I want to see what errors I get. So let's see. So it takes you to the error list, and you can see again it says expected a syntax error, semicolon missing before the curly braces, and you can see here it also has put a little bit of a red line down here. And then it says the error that it actually sees is on line 10. Now notice that the semicolon was actually supposed to be on line 9, but the program is saying that it found an error on line 10. And so just keep this in mind, that this location is not very accurate. In fact, in some cases you might actually find a difference of more than one lines. If your error is called inside a block of code or inside some function which is being called by another function. Okay, so let's just add this semicolon back again, and then another experiment that I want to do is maybe remove this library function, sorry, the stdio.h, the call to this. So I'm including this initially. So let's just say if I can delete this, or I can maybe comment this out. So when I comment this out by putting 2 forward slashes in front of this, it will become invisible to the compiler. And you know, if you paid attention in the previous lecture, you would probably you should be able to guess what sort of an error to expect. If there are any guesses, you are more than welcome to write them in the chat window, what you think the error would be. But if you don't know, well, let's just go ahead and see what happens. So let's run this, and again it says, would you like to, I'm going to say no, and then look at the error. It says identifier printf is undefined. So it has not been, so it now does not recognize the printf statement, right? And why is that? That is because I told you in the last lecture, the printf is part of the stdio header file, or the stdio, or the standard input output library of header files or header file. So if you don't include it, then the compiler won't be able to recognize a function or a statement, which is in this case is printf, which basically is part of the stdio.h header file. So that's something interesting. So if we go back and put that back in, we uncomment it, and if we run again, what you will actually see is that your program actually starts to run very nicely again without any errors. The next thing that I kind of want to point out is you'll actually see the different colors. You'll actually see different words highlighted with different colors. You'll actually see this, these keywords void and then int basically highlighted in blue, and then some other keywords highlighted in yellow. So main is yellow, printf is in yellow, and then some lines are in orange. Now this coloring is basically done by the IDE, and it basically allows you to kind of easily be able to read the code, and it also kind of groups different types of keywords with the same color. So what it shows you is that, you know, maybe int and void are similar, that's why they are both in blue. Maybe main and printf, since they are both functions, they are both in yellow, and welcome inside this braces is orange, so it's obviously different from the other three. Now another thing that I wanted to point out was this void statement. So what does this void statement do? This void statement basically tells your compiler that the main function does not need any arguments. You can actually get rid of this, and your your program would still run. So let's go ahead and give that a try. And it still runs, so great. But normally, so void basically means that no argument is going to be input to the main function. So even if you leave it blank, it would still not have any effect, but generally people encourage, or the convention is to actually specify a void rather than leaving it blank. So we're going to put that back in there. Another thing is that in this case the function actually, you know, we've put that you know, it returns an integer even though it really is not returning anything. We can also replace this with a void. So you could write this as void main void, and then see if it works. So yeah, it works. But again, generally standard practice is to put an integer back in there, so we just put int back in, and then if we run the program again, it should work. Okay, so next thing that we should probably look at is the printf statement, and maybe we want to look at that in a bit more detail. So now if we get rid of this \n at the end of this printf statement, let's see what happens. So the program still runs, you still get an output welcome to C, but there's one very small subtle difference. If you remember, in the previous case, you had a blank line after the welcome to C, and that was because you had a \n, and that was telling the compiler that you wanted to go to the next line, and that was basically printing that line. Let's quickly put the \n back in and double check, and you can see that there's a black line here, sorry, a blank line here now. Okay, you could kind of add more \n's, so you could just put these on multiple lines, and you know, now you're going to have welcome, then a new line 2, then a new line C, and then another new line. So let's quickly see how that works. And you actually see welcome to C, and then you have another \, so another new line. Okay, now if you do not put any \n's, then obviously it does not print a new line. Let's now split this into multiple printf statements and see how that goes. So you know, let's just write this as printf do printf and see what it does. Okay, and you notice that it all, even though we were writing this in 3 separate printf statements, it put all the statements in one line without any spaces. In fact, even got rid of the spaces, and it got rid of the line as well. So if you want to introduce the lines, you will have to explicitly add them here using the \n and then running it, and you actually see that it finally does that. Now we looked at some other statements as well, which were, you know, \t, which we said would introduce a tab. So let's just say we want to have a tab between, or maybe between the welcome and the to word, and then between 2 and C. So let's do that, and let's see what happens. So you get tab between welcome to and then C. Now notice that tab does not cause like uniform spacing, and that's why people generally don't recommend using tab too much. If you want to have exact sort of spacing instead of tab, so if you wanted 4 spaces, it's probably better to, you know, add 4 spaces manually, 1, 2, 3, 4, and then tab 4 spaces here as well, 1, 2, 3, 4, and then if you run this, you actually see that this gives you uniform spacing. So tab, when you're printing text, is something that people generally do not use too frequently now. Okay. Right, a few of the other things that we wanted to check, maybe let's just write this as welcome to C, and there were some other special characters that we looked at. Let's just say \a. We said that this would produce a sound. Let's see what sort of sound it produces. So let's play and hear the sound. So so you get the standard Windows tone. In this case, if you're using some other operating system like Linux, you might hear a different sound. Another thing that I wanted to show you guys was, let's just say you wanted to include this C inside double quotes. Now if you include the C in double quotes, you'll actually see that you would expect some sort of an error. In fact, if you run this, you actually get multiple errors. You get undefined operator and things like that, and the reason for this is double quotes here have special meaning, and they've kind of broken up the way how the printf statement is structured. So if you want to include the C inside double quotes, you have to then add a backspace before that, and then another backslash before these. And so what this then tells the compiler is that when it actually comes to this part, that okay, backslash, and then it has to say, okay, I need to interpret the double quotes differently than I normally do. So the backslash or the escape sequence basically indicates a special condition, and that's the special condition in this case. So now let's go and see if it actually does what we want it to do. And let's see. Yes, right. So what it's done is it has included the C statement inside double quotes. Okay, what more could we do? Let's just say we wanted to print a backslash in our statement. So let's just say welcome, and then maybe we want to say, I don't know, marhaba. So marhaba in Arabic. So if we wanted to print like a double slash or maybe even a forward slash, I guess, we would first have to write a backslash before that. Right, let's get rid of the backslash and then see what happens. I'm not sure if the forward slash has special meaning. No, it doesn't, but let's just say if we wanted to have like a single backslash printed, if we did that, then we might actually not be able to print this. Yeah, it doesn't print it, right? So if you want to print like a backslash, you have to write two backslashes. I mean, this is something which you could use when you're writing maybe a directory path or something. Maybe something like, let's say something like, let's say you wanted to write something like file path C backslash docs backslash home. Right now, if you did this, you will not be able to see the backslashes, and if you want to see the backslashes, you have to have an escape sequence before the backslash, so it is interpreted in a different way than it normally is. Let's do that. You actually see that you are now able to see this. Right, one final thing that I want to talk about is what is called a cout stream, which technically is not C code, it's actually from C++, but we're going to discuss it because sometimes you'll actually find cout streams statements embedded in C code as well. So let's just quickly look at this. Cout is somewhat, in terms of what it does, it's actually identical to or very similar to printf statement, and you just have to write it as cout and then these two less than signs and then your statement. Now notice that with the printf we were using parentheses to indicate this what we wanted to send or to surround the argument of what we were. Argument is basically what we were passing to the printf function. Now notice in this again we're sending this statement of text that we want to be that we want printed on our screen, but in this case we're not using parentheses, we're using something different, and that's because cout is actually not a function. So printf statements, or statements which basically are followed by brackets or parentheses, for example the print f statement or the main, are basically functions. Cout is not a function, it's actually a stream, and if you want to use this, you have to use this less than sign twice. Another thing is that if you want to use the cout statement, you have to include the library which it comes from, which is basically iostream. And one more thing that you need to do is write it as std and then these two colons, and then it should work. Okay, let's now see what happens. So you get welcome to C printed in both, so you get the same thing. Right. So another thing is that if you don't want this std cout and you have to write multiple cout statements, you can also replace this with name space std. So another thing that you can do in this case, another way of writing this is if you have many cout statements in your program, what you can do is maybe replace this or add another statement on top using namespace then you don't have to include this, and if you run it, it should work. Well, it didn't. Let me quickly see what's wrong. Yeah, so I basically need to add a semicolon after this, and then it should work fine. Okay, it works. So in addition to cout, there's also another stream which is called cin, and that is when you actually want to take data as input from the user and send it to the computer, and we will talk about that a little later, but we just wanted to mention cout because cout and cin, a lot of the times you'll find code in C which is basically C code, but also uses cout and cin for input and output, so it's important to just be familiar with those. But that's pretty much all the C++ that we're going to talk about. We're primarily going to be talking about programming in C after this.